problems in this video use the same sort of principles and ideas that we learned in our last video on solving equations, but they're a little bit tougher in nature just because of how they look. The actual math behind them is still very much the same thing. So in this first problem here, our job is to solve for t, but right now, t is inside of some parentheses. So we have two options on this problem. The first way you can do that, if you remember, you work in reverse PEMDAS. So we have parentheses, we have m for multiplication. So we would actually have, we have a times -8 there. One option you have, which I'm not going to I'm going to show it another way, but if you wanted to, you could just divide both sides by -8. You'd get -2 equals just t minus 3, because the -8s would cancel. And then you solve that like a regular equation, and it's not too bad to do. But I'm going to go about this problem a different way, because it's the way I find that kids usually prefer to do this problem. If you liked that first method, great. That works perfectly. But I'm guessing a lot of people probably would have wanted to distribute here. It's kind of a natural thing that people like to do with problems when they see parentheses. So you get -8t. -8 times -3 is a positive 24. And that's equal to 16. And now it's just like a normal problem that you solve for t. We're going to subtract our 24 from both sides. You get -8 equals -8t. These are going to cancel. You divide both sides by -8s. And you end up with t equals 1. On our second problem here, the fact that we have a fraction in our problem is undoubtedly going to bother some of you guys. Fractions are something that kids just do not care for, and I've shown you in videos, in the Chapter 0 videos, how you can deal with fractions, but a lot of times kids do decide to turn them into decimals and just deal with it that way. That is an option, but because this decimal repeats, it's not as good if you just do like a 0.6 or 0.66. Like, it's better to be able to deal with the fraction when it's not a nice decimal. So I'm going to distribute just like normal here. 2/3 times 6, remember that's like times 6 over 1, and multiplying fractions, you just multiply the tops and multiply the bottoms. I'm going to get 12 over 3, and 12 over 3 is just 4. So I get 4 minus 2/3 times -1 is just going to be minus 2/3 p equals 10. Well, I got to get this 4 out of here, so I subtract 4 on both sides. I get -2/3 p equals 6. Oops, forgot my line on these, and this one too for that matter. When I get to this point, I want to get p by itself. It's -2/3 times p, so I'm going to divide by -2/3. Remember though, when you divide by a fraction, you're going to keep change flip. That's the same thing as multiplying by 3 over -2, which is the same thing as -3 over 2. So we're going to multiply both sides by -3 over 2. And when you do that, these will cancel. You just get p. And actually, when you look at these fractions canceling right here, you end up getting 6 over 6 when you multiply straight across. And that's just 1. So it's just 1p equals -18 over 2, which is -9. And for our final problem right here, they want to know, is x equals -4 a solution to this equation? That should be a 6 right here. And on this problem, you could go ahead and solve the equation. There's nothing wrong with doing that. If they give you the number though, like if this is a multiple choice test, they want to know, is this particular number a solution? You can also just plug it in and see if it works. So you can distribute like on the other ones, and that would be a good thing to practice if you wanted to. Or just plug it in and see. If you plug in a -4, you get this. -4 plus 1 is -3. So I have -2 times -3, and I want to know if that equals 6. Yes, it does. I get 6 equals 6. Oops, that's a little bit off screen there. That checked out, so that means that it is a solution.